Okay, so for whatever reason, there does not exist an example 8. The last example was 7, and now this next example is 9. So don't be freaking out thinking that you're missing something. There's not an example 8 here. Well, because there's not an example 8. So on example 9, let's look at f composition g of x, and also we will write the domain in interval notation. Let's have f of x. There it is. It's x over x plus 4. And g of x will be 3 over x squared minus 1. And so when we are asked to simplify or find f evaluated at g of x, that is what f composition g of x means to do. Once again, we're going to work from the inside out, so we're going to take f evaluated at g of x is equal to 3 all over x squared minus 1. Okay? And so what that means is that we're going to go to our our f function, and where we have an x, which was there and there, we're going to be replacing that with 3 over x squared minus 1. Okay? So for our f function, we're going to have the x, which we're replacing that with 3 over x squared minus 1, all divided by the 3 over x squared minus 1, and then our f function says plus 4. Okay? So yeah, we kind of got a mess up here, and it is a mess that includes a complex fraction. I think one of the easiest ways to simplify a complex fraction is to multiply the numerator and the denominator by a creative form of 1. And that creative form of 1 that we're going to use is going to be the least common denominator of the denominators within your complex fraction. So I'm going to multiply by x squared minus 1 here, as well as in the denominator. And I'm just writing those over 1s so that you will see when we go to multiply the numerator there, when we multiply the denominator, we've got to multiply both terms in the denominator. Okay? Let me see, I'll switch to black here. We'll end up getting that the x squared terms reduce, leaving us in our numerator of our fraction with just 3. That's it. And then in the denominator of our fraction, we'll have the x squared minus 1 factors reduce, leaving us with, for the first term, a 3 plus, and really all we can do here, because we still need to run that x squared minus 1 through, is we still have 4 times the quantity x squared minus 1. So once we simplify this, we'll have 3 over 3 plus 4x squared minus 4. And I think that we can simplify some of that in the denominator. So f composition g is going to be equal to 3 over 4x squared minus 1. There's f composition g. All right, so for the domain of this composition function, we are going to need to inspect what is the domain of the composition function itself, as well as the inner function, the g of x. Okay? So I'm worried about 0 in the denominator of those fractions. So I'm going to take the 4x squared minus 1 and see what values of x make it be 0. Add 1 to both sides. Divide both sides by 4. Then we're going to take the square root of both sides, not forgetting our plus or minus symbol. So the x values of both positive and negative, square root of 1 is 1, square root of 4 is 2. Those are not in our domain because it makes the denominator of this fraction be 0. If you want to pause the video and check, you can. Next, we are going to inspect the domain of the inner function, which was the g of x. I'm looking at that x squared minus 1, and I'm going to say what will give us 0 in the denominator of that fraction, so I'll set it equal to 0 and solve for x. Add 1 to both sides. To solve this quadratic, again, take the square root of both sides, not forgetting the plus or minus. So we'll have x is equal to positive and negative, square root of 1 is 1. All right, the domain here is going to be pretty messy. So I say what let's do to kind of organize our stuff is let's draw a big number line and let's X out the bad values, okay? Negative 1, no good. Positive 1, no good. Negative 1/2. Negative 1/2, no good. All right, and positive 1/2, no good. But our domain is anything else. All the stuff in between there, all the stuff in between there, all the stuff in between there. We got a lot of ors going on here. Okay, so for our domain, let me see, what color do I want to use here? Blue, maybe. To express the domain of that function there, f composition g, it's going to be negative infinity to negative 1, unioned with negative 1 to negative 1/2, unioned with negative 1/2 to positive 1/2, unioned with positive 1/2 to positive 1, unioned with 1 to positive infinity. And that checks, I believe, all 5, 1, 2, 3, 4, 5 pieces of the number line for our domain.